Hello and welcome to this video on AC power. AC power is what comes out of the mains in your house, compared to direct current, which is what you get out of a battery or such. AC stands for alternating current. Alternating current, because that's what AC power is. It's where, on a graph, your current is sinusoidal. It goes between minimum and maximum. And due to V equals IR, where R would be the internal resistance of your power source, of your power supply, the voltage would look like that. So they're both in phase with each other, which means they're both over top of each other. And V, this one's V, that one, small one's I, are times by the internal resistance R. The time between peaks of each of them, that there, is called the time period, if this axis here is T. And the number of time periods you have in a second on your power supply of the source is the frequency. So if you have 50 peaks per second, as you would in the UK, for 50 Hz for a mains power supply. On AC circuits, on AC power supplies, you have a peak value. So for example, the top there, that's the voltage peak, as you would with current peak. Voltage and current peak, they're not hugely useful for calculating things like power, because it's only at those values for a very, very short amount of time, instantaneously as it goes past it, before going back down again. You can't take the average either, though, really, of an AC circuit, because that would be zero. Because the average of a sinusoidal wave, it spends the same amount of time positive as it does negative. It would simply be a flat line if you wanted to average it. So something else is used called RMS. RMS stands for root mean squared, and this is used to find power in an AC power supply, where power is exactly the same as it was before. There's IRMS times by VRMS. Now, to get RMS value from the peak value, you simply get peak and divide it by root 2, and root 2 is roughly 1.41. The reason you divide by root 2 is, if you imagine here, you have one little bit of a wave. If your peak value is up here and you divide it by 0.41, it'd be roughly about here. And then on your wave, you have the same amount of area below, between the axes and that, as you do above. Hence why on a sinusoidal wave, root 2 gives you the RMS, or RMS equals peak over root 2. And as you'll notice by this, frequency does not affect power at all. It's all simply the height, the amplitude of the voltage and the current, which is affected by our internal resistance over here, but is not affected by frequency at all. So I hope you found that video useful. In short, AC power stands for alternating current. You have two sinusoidal waves in phase with each other for current and voltage, due to V equals IR. The time period is the difference between the two maximums. Root mean squared is used to calculate power, P equals IV, but IRMS and VRMS. And to get RMS, you take a peak value and divide it by root 2, which is roughly 1.41. Hope you found that video useful. If you'd like to see more of them, then please subscribe. Have a nice day.